Hi everyone. Today we'll discuss Euclid's axioms. So for that, let's first understand what axioms are. So axioms are statements that are to be considered true without any proofs. So this is when Euclid was building up the concept of geometry, and so he had to give some statements that should be considered true without proofs where he can build more concepts on. Now, some of the axioms that Euclid gave were Now in this class, we'll be discussing the first three axioms. So let's take the first axiom and let's take the help of an example. So if we have a circle whose area is 10 meters square and we have another triangle, say B, whose area is 10 meters square, then we can say that area of A is equal to area of B, which is equal to 10 meters square, or we can simply write as area A is equal to area B. Now keep this aside and let's take another example of a square having area as 10 meters square again. So with the same idea, we can say that area B is equal to area C, which is equal to 10 meters square, or we can simply write area B is equal to area C. Now let's look at both the facts together. So we have area A is equal to area B, and from the second one we know that area B is equal to area C. So if we take all of them together, we get that area A is equal to area B is equal to area C. And now if we just ignore the B triangle, we can clearly get that area A is equal to area C. Which means that earlier we had area A equaling area B. In the second example, we had area B to be equal to area C. And from the entirety of it, we can say that area A is equal to area B is equal to area C, which gives idea to the first axiom that says that things which are equal to the same things are equal to one another, which we saw that this area of circle was equal to area of triangle, but this area of triangle was equal to area of square. So both the area of square and the area of circle was equal to the area of triangle, which means that area of circle is also equal to the area of square, right? And now let's think about this axiom. Let's think about each of the words clearly. So in this, the first word, things. What are things here? And similarly, what are same things here? Now in general, when we're talking about Euclid's axioms, when we say things, we're referring to some sort of magnitude. And so the same things would be same kind of magnitude. In the sense that if I take a line whose length is 3 meters, and I take a square whose area is 3 meters square, we can't say they're equal simply because the value of both area and length is 3. Because yes, they are both magnitude, but they're not same kind of magnitude. While this is length, this is the area. And we can also see that here, length is 3 meters, where area is 3 meters square. So they are not same. And so we can't compare this using Euclid's axiom 1 and say that they're equal. So this would not be equal. So we have a first axiom done. Now let's move on to the second axiom. So let's take another example where we have a line AB whose length is given as 3 meters. And we have another line CD whose length is given as 3 meters again. Now we have AB equals to CD because both of them have the same length. Now let's take another set of lines, EF having length 2 meters and GH having length 2 meters again. With the same idea, length of EF is equal to length of GH. Now what if in this equation I add EF on both sides? So we get EF1 here and another EF here. But because of this, we also know that EF is equal to GH. So this is GH. But now the idea that this will give is that if we take all of them together, we have AB plus EF equals to CD plus GH, which we can see in the illustration is simply adding both these lines. And so AB plus EF would be AF, whereas CD plus GH would be CH. And we can see by arithmetic that both of them should be equal. And we can also see it in the illustration because this length would be equal to 5 meters and even this length CH would be equal to 5 meter. So it makes sense why both of them are equal, which is AF equals to CH equals to 5 meter. But what did we really do here? We had a set of equals, AB equals to CD is equal to 3 meter. We had another set of equals, EF is equal to GH is equal to 2 meter. And then we added both of them. We added both the equals to get that the wholes, that AB plus EF is equal to CD plus GH. So when we had two pairs of equals and we added them, the wholes were also equal. And this is the idea of axiom, which says that if equals are added to equals, then the wholes are also equal. But we can't limit this to just addition, right? We can also see subtraction here. Now let's take the same example only. Instead of adding here, let's subtract. So we are just taking this line out of this line, which means that AB minus EF is equal to CD minus GH. And what we get here is when we shorten both the line by these lengths, we get AE would be equal to 1 meter, whereas CG would also equal to 1 meter because 3 minus 2 is 1 meter. And this can also be shown with arithmetic that AB minus AF would be equal to AE and CD minus GH would be equal to CG. So AE is equal to CG, which can also be seen here because both of them are 1 meter. And so this idea also follows in subtraction, giving that when we have two equals, AB equals to CD equal to 3 meter, and we have another equals, EF is equal to GH is equal to 2 meters, then the remainders of the subtraction would also be equal. So this is AE is equal to CG is equal to 1 meter. And this is the third axiom, which says that if equals are subtracted from equals, then the remainders are also equals. So in this class, we saw the first three axioms. If equals are added to equals, the wholes are also equal. And if equals are subtracted from equals, the remainder are also equal. In the next class, we'll see the remaining axioms. Thank you.